This lesson is on dividing polynomials by monomials. Consider if you had two terms divided by one term. In the simple case, 5 plus 15 divided by 5. On one end, this should be 20 over 5, which gives us 4. So we know the answer should be 4. Another way to consider it would be to split it up and say that I'm going to divide 5 by 5 and 15 by 5, which then gives me 1 plus 3, which also equals 4. So we can use this idea of splitting up each term and dividing it separately by the denominator to achieve an answer. So dividing a polynomial by a monomial, we can use this property of creating it into single fractions, and then we can simplify each fraction. So let's take a look at how we would do that in these examples. In this case, we have a polynomial and a monomial that it is divided by. Notice that there is no way to combine the numerator terms because they are not like terms. Therefore, we need to separate and divide 6x cubed by 18xy, and also divide 9xy squared by 18xy as well. Now, because there are no additions or subtractions in the numerator, we can use the simplification property and divide anything that needs to be divided. So 6 and 18 can simplify by dividing numerator and denominator by 6, leaving us with 1 and 3. So we've got a 1 and a 3 in the denominator. And then we've got x cubed divided by x to the 1, which is like x to the 3 minus 1 using our properties of dividing exponential expressions. And then we've got our y to the 0 minus y to the 1. So we're dividing, and really nothing happens to the y, it just stays there. But if you were to do it in this manner, you would see that it would give you y to the negative 1, which means just leaving it in the basement. So you could just leave it there if you'd like. Next, we've got 9 over 18, which we can both divide by 9, giving us 1 and 2. So 1 over 2, and then x to the, and these x's just cancel, 1 minus 1, and y to the 2 minus 1. So this gives us 1/3 x to the 2 and y to the negative 1, and minus 1/2 x to the 0, y to the 1. Now we don't want any negative exponents, so let's just rearrange these. The 3's left in the bottom, the x squares on the numerator, y to the negative 1 becomes y to the 1 in the denominator, and negative, the x to the 0 is just a 1, it's gone. The y to the 1 stays up top, and the 2 is in the denominator. So we have now an expression where this original expression has been simplified. So x squared over 3y minus y over 2. In the next example, we need to first expand the numerator, collect any like terms, and then we can use this afterwards. So let's do that now. We've got 3x times 3x is 9x squared. 3x times y gives us positive 3xy. And then negative y times 3x gives us negative 3xy. And negative y times positive y is negative y squared. It's all over 3xy. But let's collect the like terms in the numerator first. The xy terms can be combined, and they actually disappear. Remember, this is actually the difference of squares formula. So if you notice that originally, you could have just skipped that step and said, I know that because I have this first term and last term the same in both brackets, and we have a minus and a plus, I'm going to take my first term squared minus my last term squared. Everything is over 3xy. So now let's simplify that. Each component will be over 3xy, and we will simplify anything that needs to be simplified. So in the first term, the 9 and the 3 can become a 3 over 1. The x squared and the x can cancel, and you'll notice x squared over x just becomes x in the numerator, and the y stays the same. So you could do it either this way, the full long way, using the properties and the rules that have been already explained, or you may see it as, oh, I had two x's up here and one of them canceled, so I have one left. So that's 3x over y. And here you have y squared over y, which is y over 1, minus y over 3x. So I have shown you two approaches to simplifying exponential quotients. You can choose whichever one you feel most comfortable with. However, you need to watch out. Every time you see something like this, it is very common to say, oh, is this not just 3x? No, it's not. Because you cannot cancel if you have a plus sign or a minus sign. You can only cancel if all terms are being multiplied. So it actually is 3x over 5 plus 5 over 5, which is 3x over 5 plus 1 is the simplest way to write that. So this comes from the idea that, hey, if you had 2 plus 4 over 4, you could not say that that's equal to 2. Because 6 over 4 is actually 3/2, which is not quite 2. So remember, you cannot cancel terms when they are added or subtracted.